Good morning, everyone. Let's start with today's topic that is balance. It's a continuation of the previous video. The link of the previous video is in the description box below. Coming to the contents, three main terminologies of balance. What is the difference between balance and coordination? CNS responses towards balance, types of balance, mechanism in order to maintain balances, correlation between static and dynamic balance. Three main terminologies, that is your COG, LOG, and base of support. COG is nothing but center of gravity, which is usually lying in normal human individual anterior to the second sacral vertebrae. LOG is nothing but line of gravity which is passing through the COG, that is your center of gravity. BOS, base of support. In generally, when a human being is standing or when man is standing, is the area between 2 feet. If LOG, that is line of gravity, falls within base of support, the body is termed as stable. If the LOG, that is line of gravity, falls ahead, behind, or away from the base of support, that body is termed to be unstable. Consider this line to be your LOG and consider this one to be a human being. Biomechanics book by Cynthia Norkin says that if the body's height is too much, that is, if COG, as center of gravity, is far away from BOS, body is termed to be unstable. Whereas when the COG, that is your center of gravity, is closer to the base of support, the body is more stable compared to the previous example. Consider this to be your body and the blue line to be your LOG, that is your line of gravity. The body has good height, hence the BOS is very small to that respective body. When the body shrinks down, that is the COG comes closer to the BOS, definitely the body has a greater amount of BOS compared to the previous example. Coming to the differences. Balance is nothing but maintenance of certain body position in that particular position. Let it be a static or dynamic. Let it be a stagnant position or when the body is moving. Whereas coordination is nothing but smooth and accurate movement with a purposeful nature. That is movement of a body part which is smooth and accurate with a purposeful manner. Types of balances, static and dynamic, whereas coordination, there is no type. Either it is in coordination or coordination. Balance, systems involved in order to maintain static or dynamic balance is nothing but visual, vestibular, and somatosensory. Sorry, it is not sensory, it is somatosensory. We already dealt it in the last class. I'll still put up the link in the description box below. Coordination. Coordination was a different video. You can go back to the videos and check what about if you want to learn more about coordination. Still, to differentiate between balance, the systems involved in coordination are kinesthetic sensation, antagonistic muscle, neuromuscular junction, and spinal cord. Coming to CNS responses. There are two types of CNS responses in order to maintain balance. Let it be a static or dynamic. Reactive response and proactive response. Imagine you're walking. You step on a thorn. What your body does? Your body basically withdraws your foot from the thorn. That is not registered in your brain. That comes within fraction of second. That is nothing but reactive response. Still, even if you withdraw from the thorn, your foot, you still are capable of maintaining balance. That response generated by CNS in order to maintain balance is known as reactive response of CNS for providing balance to the body. Let this example be in static or let this example be in your dynamic. Coming to proactive response. You're sitting for a while watching a movie in your living room. You start feeling hungry. Your mom calls out your name from the kitchen telling that the plate is ready. So you know the plate is ready. You know you have to get up from the chair, walk down to the kitchen, take the plate, come back to the chair, sit on the chair, and start eating. This is all a process generated in your brain when you feel hungry. This is a proactive response. Your balance types of balance in this action is both static and dynamic. You're sitting, you're feeling hungry. The brain is registering the hunger. The balance at that position is static. Getting up from sit to stand position, dynamic balance. Walking down to the kitchen, dynamic balance. Standing near the plate, grabbing the plate, static balance. Coming back to the chair by walking manner, dynamic balance. Stand to sit position on the chair, dynamic balance. Sitting and eating, static balance. So, in order to maintain this balance, when you're hungry, go to the kitchen, come back to the chair, sit and eat, is nothing but your proactive response provided by the CNS in order to maintain balance. Coming to types of balances, as we have already been stated, we'll just look at what are the types of balance: static and dynamic. Static is nothing but, as the name tells, it is stagnant. Balance required to maintain the body in a balance in a stagnant manner. The ability to maintain a body in a fixed position is nothing but static balance. Static balance is nothing but maintaining the COG within your BOS when the body is not moving or when the body is at rest. Exactly opposite is nothing but your dynamic balance. It is the ability to transfer the COG in vertical projection so that every time you move, the COG falls within the BOS. Now, how the COG generally travels when you walk? Example consideration: when you walk, COG always moves in a sinusoidal wave. I have already told ability of transferring of COG in a vertical projection so that the COG falls within BOS is nothing but your dynamic balance. So if COG is moving in a sinusoidal curve when you walk, let it be a positive peak or negative peak, COG is definitely traveling vertical projection way. Hence, whatever the traveling positive or negative, let it be a vertical projection in the sinusoidal wave. Every time when you walk, COG must fall within BOS, or else it cannot be termed as dynamic balance. Coming down to how to maintain, how a body maintains itself in order to maintain the static balance. That is mechanism provided by the body in order to maintain static balance. First one is optimal strength of trunk and lower extremity musculature in order to maintain erect posture. If this musculature is not doesn't have optimal strength, the overactivity of the stronger muscle can lead to fall of the body. Second point, normal proprioception. As I've already been discussing in the last video, the first part of balance, proprioception for static balance maintenance is very importantly provided by your joint position sensors, partly provided by muscle proprioceptors. Coming down to the third point, normal vestibular and visual reflexes in order to maintain head on body and body on head alignment, as we already saw in the previous video. Fourth one, cerebellum. And fifth one, entire brain. Though cerebellum is a part of brain, I've still quoted it in the different point because cerebellum is very important when we are talking about static balance. Coming down to dynamic balance, optimal musculature power not only of the lower extremity and trunk but of the entire body is needed when you walk, when you jog, or attaining any dynamic balance. Second point, normal proprioception is very important when you are talking about dynamic balance with respect to both joint proprioceptors as well as muscle proprioceptors. Third point, it's the same compared to the first one, that is your mechanisms in order to maintain dynamic balance. That is normal vestibular and visual reflexes to maintain the head on body and body on head alignment, as we already saw in the balance part 1 video. Fourth one, cerebellum and basal ganglia. As we saw on the previous slide, that cerebellum was very important in order to maintain static balance, whereas in order to maintain dynamic balance, cerebellum and basal ganglia are very important. And utmostly, do not forget the entire brain in order to integrate the sensory system, in order thus maintaining the balance. Coming down to the last part, correlation between static and dynamic balance. Now, as we learn, as we understood that there are two types of balance, static and dynamic. Taking the same example for proactive response of CNS when you're hungry and your mother calling about the plate is ready from the kitchen, grab up the plate, come back to the same position, sit and eat. This was your proactive reaction from the CNS. Here, the correlation existed between static and dynamic balance as well. So, what is this correlation? When we are talking about static balance, the joint position is maintained in a single position. Thus, the muscles are co contracting in order to maintain the joint in a certain position for a longer duration. This co contraction of the muscle is known as stabilizing force at that particular joint. When a person is moving, continuously flexing his knee and extending his knee, one muscle undergoes eccentric contraction, whereas the antagonist muscle undergoes concentric contraction. This is nothing but destabilizing force occurring on the knee joint. The equilibrium between destabilizing and stabilizing force, along with the required sensory receptors, that is your visual, vestibular, and other proprioceptors, for maintaining balance is nothing but the correlation between static and dynamic balance. So this was the end of the balance part 2 lecture. Let's meet you all in the next video dealing about evaluation of types of balances and conditions where the balance is affected, why they are affected, and how to treat them. Thank you, one and all. Stay safe.